Herbert Eugene Ives was born in 1882 and he died in 1953. Einstein's dates are 1879 to 1955, hence they were almost perfect contemporaries. A Philadelphian by birth, Ives did his most important work in New York City as the director of electro-optics at Bell Laboratories, at one time overseeing 200 technicians and engineers. In 1927, Ives was the project engineer for the first long-distance demonstration of television. Ives personally held patents on 102 inventions related to color photography, facsimile, television, phosphorescence, illumination, photometry, and photoelectricity. For the military, Ives pioneered high-altitude aerial photography and night vision. Those 3D novelty cards where the object appears to move are another Ives invention. Ives co-founded and later presided over the Optical Society of America. He was vice president and physics chairman of the American Association for the Advancement of Science, and he was an elected member to the National Academy of Sciences. In 1937, after Ives had freed himself from practical duties at Bell Labs, at least temporarily, he fired off 5 theoretical physics papers. At that time, Einstein's theory of special relativity was achieving orthodoxy. Most American physics professors, certainly the European imports amongst them, championed the relativity of time, and they denied the existence of an ether. This followed Europe's lead. In a decision that caused street demonstrations, the Society of German Scientists, at their centennial celebrations in 1922 in Leipzig, censored any criticism of Einstein. A similar closure of debate occurred in Britain when Cambridge University published in 1923, Mathematical Theory of Relativity by Arthur Eddington, the man more responsible for the Einstein myth than Einstein himself. Also in 1937, Ives and his assistant, G.R. Stilwell, conducted experiments on the Doppler effects of light emitted from rays of hydrogen ions. Ives invented a Canel ray tube specifically for these experiments. The duo performed their experiments twice, and they published their results in the journal Nature in 1938 and 1941. To Ives, the existence of a Doppler effect in light proved the existence of an ether. The Einsteinians, however, immediately claimed that his experiments proved their special theory of relativity. Modern textbook accounts of the Ives-Stilwell experiments neglect to mention that its authors both intended to and claimed to have refuted Einstein. When Ives left the American Association for the Advancement of Science in 1939, his retirement speech assailed the special theory of relativity. Over the next decade or so, Einsteinianism achieved full orthodoxy. Physics journals blockaded any papers critical of relativity. Debates over relativistic and quantum phenomena disappeared from the textbooks. And, just polite, discreet marginalization morphed into outright blackballing. Ives was the exception. As the revered founder of the Optical Society of America, they continued to publish his papers in their journal. Big physics, however, ignored him. Ives' truculence grew the more he investigated the history of the special theory of relativity. His swan song, published in the year of his death, 1953, was titled Genesis of the Question, Is There an Ether? That paper was in response to a 1951 paper from the famous physicist Paul Dirac titled Is There an Ether? Wherein Dirac, albeit amidst the obligatory obfuscations, conceded the necessity of an ether. Recounting the views of earlier 20th century physicists, the luminaries, Ives stresses, in the proposals of Fitzgerald, Lorentz, and Larmor, there is no suggestion of a non-existence of the ether. And the suggestion that the ether is non-existent is not to be found in either Poincare's or Lorentz's discussion of relativity. In fact, Lorentz explicitly affirmed his adherence to the ether. Poincare's text, Principle of Relativity, defined motion relative to an ether. Larmore's Ether and Matter and Lorentz's The Theory of the Electron both presumed an ether, with the latter, Lorentz, stating, "I cannot but regard the ether, which is the seat of electromagnetic energy and its vibrations, as being endowed with a certain degree of substantiality, however different it might be from ordinary matter." Ives, like Dirac, dated ether's banishment to a specific event. Ives: "The idea that there was no ether appears for the first time in the paper by Einstein in 1905 titled On the Electrodynamics of Moving Bodies." Of course, Einstein not only tossed out the ether, he also discarded three-dimensional space and absolute time. For substitutes, Einstein offered trendy, kooky, continental European nostrums borrowed from Minkowski's space-time theory and from Riemannian geometry. The ecstatic adulation Einstein's scribblings attracted copied contemporaneous crazes over abstract avant-garde art forms. Not only did Einstein play a marginal role in early relativity theory, his belated contribution deprived prior commentary of any physical meaning. To Ives: "All the principle of relativity requires is that any set of measurements we make on light signals with respect to one body shall yield the same result on any other body in uniform motion with respect to the first, if made by instruments partaking in the motion. Conversely, measurements of a light signal made from bodies moving in different directions and speeds will yield different results, which is what the Ives-Stilwell experiment revealed." To Ives, the ether explained electromagnetic phenomena, like visible light, in an intelligible manner. Removing ether from the picture, as the Einsteinians demanded, entailed brain-splitting, counterintuitive distortions of time and space. Electromagnetic spectrum, the electromagnetic part, is a misnomer. Nevertheless, this spectrum goes from microwaves to radio waves to visible light and beyond. The operative word here is waves. Waves are undulating motions, be they flaps or ripples, be they shakes or shivers, be they quakes or quivers. Waves are lengths of water arching before they break upon the shore. Waves are regularly recurring disturbances moving through a medium with little or no associated material transport. Wave oscillations convey force, not mass. Waves vibrate around fixed locations. Sound waves propagate via air molecules bumping into their neighbors. Seismic tremors tremble through the Earth's crust. The study of waves is called wave mechanics. All waves are mechanical, including microwaves, radio waves, and light. Let there be no talk of waves without acknowledging the mediums through which they travel. Mediums are the intermediary substances transmitting the wave. Mediums carry disturbances from one location to another. Mediums are the ambient material through which forces act upon remote objects. Mediums are the go-betweens, the agencies conveying the wave. Through the intervening substances of mediums, waves impact human senses. Earth's atmosphere is the vibrational medium through which sound travels to our ears. Earth's crust is the medium through which our bones get rattled by an earthquake. Ether particles are the medium through which light travels to our retinas. All particles are comprised of smaller particles. This process of division descends indefinitely to the infinitesimal. Ether particles are both the components of nucleons and electrons, and they are the constituents of a transparent ocean in which our tangible molecular world floats in suspended animation. Conventional optical microscopes can espy an object 1/50th of a millimeter in diameter. Electron microscopes allow the study of objects 1/10,000,000th of a millimeter in diameter. This includes carbon molecules, at least the ones trapped in crystal formation. Protons are far too small to be seen by an electron microscope. Electrons themselves are 1/1000th the size of protons. The size of ether particles is unknown, but they are obviously magnitudes smaller than electrons. The Sun is 1.4 million kilometers in diameter. The Sun is mainly comprised of hydrogen atoms, which are basically protons, each of which is 1/quadrillionth of a millimeter wide. The star-to-proton shift is but one small step in the grander cosmic staircase of scale. Ether particles may be as tiny compared to a proton as a proton is to a star. Scientists will not isolate ether particles anytime soon. Nonetheless, ether definitely impacts our proton-based world, and it wreaks havoc upon electrons. Space-filling ethereal particles transmit electromagnetic waves, and they propagate gravitational force. Controversies surrounding relativity, back when controversies were tolerated, often turned on reference frames. Motion had to be defined with respect to specific bodies, which were always themselves in motion. Hence, it was claimed that there was no ultimate reference frame and no universal clock. Ives and company contended that the ether provided this absolute reference frame. Bodies moved through and in relation to the ether. Time ticked in lockstep universal simultaneity relative to the ether. Such was the prevailing pre-Einsteinian view. Einstein's own writings betray an acceptance of the ether, at least until 1895. Not long thereafter, Einstein and company began exploiting the difficulties in detecting the ether to outright deny the ether's existence. In a 1920 stumble, Einstein conceded that the transmission of light would be impossible without some form of ether. Then, in trademark obscurantist fashion, he attaches to this concession a befuddling statement about the impossibility of measuring any type of space-time without an ether, which makes no sense. And he further reassures the faithful that his ether lacked any ponderable mass. After ether became the dogma, merely uttering the word ether became an excommunicable offense. Algebraic contortions jerry-rigged vacuous spacetime into a device capable of performing the mechanical role of medium for electromagnetic waves. Before Einstein, ether was an indispensable premise of electromagnetic theory. The Einsteinians demanded four-dimensional explanations of all such phenomena. From this mystical cauldron arose the phantasmagorical photon. The demise of the photon is the last chapter exclusively devoted to Ives in the magisterial The Einstein Myth and the Ives Papers, published 1979. In that chapter, amongst other things, they reprint a lecture that Ives gave upon his receipt of the 1951 Rumford Medal. In that speech, Ives goes over the wave theory of light, and he closes by quoting Count Rumford from 1798. At that time, 1798, one of the main physics controversies revolved around the calorie or the caloric. Orthodox physicists at the time believed that there was a particle of matter called a caloric, and that heat consisted of a transfer of these actual particles from hot objects to cool ones. Rumford was not a believer. Here's Rumford, 1798. What is heat? Is there any such thing as an igneous fluid? Is there anything that can be called a caloric? It appears to me to be extremely difficult, if not impossible, to form any distinct idea of anything capable of being excited and communicated in these experiments, except it be motion itself. To Ives, contemporary science faced a similar question, for it was extremely difficult, if not impossible, to retain the idea of light as consisting of discrete photons. While he recognized the difficulty in describing all optical phenomena exclusively in terms of wave transmissions, he nevertheless predicted the photon will go the way of the caloric that Rumford demolished. Industrial engineers constitute a distinct physics culture from theoretical physics professors. Pragmatists like Ives contended that over-reliance on abstract mathematical formularies pulled physics away from the real world. As an aside, even when Ives was focused on developing cutting-edge electronic technology, he never used the Maxwell equations. Ives and fellow anti-relativists, and there were a lot of them, like Arvid Rutherford, the Swedish-American battery inventor, preferred visual descriptions over algebraic hieroglyphics. They preferred comprehensible physical concepts over the mishmash of paradoxes and contradictions that Einsteinians rattle off as though they're elementary scientific principles. Ives retained three-dimensional space, universal simultaneity, and the ether. After a 50-year struggle, the heretics burned out, Ives being amongst the last of the glowing embers. Herbert Ives worked with the speed of light, literally. His life work straddled the intersection of electricity and light. His inventions demonstrably benefited humanity. He knew what he was talking about. Ives decried Einstein's denial of the ether as a descent into mysticism. He dismissed Einsteinian thought experiments as rituals. He rightly recognized warped four-dimensional space-time to be childish nonsense.